Hello students, welcome to the interesting chemistry where you will enjoy a classroom teaching experience. Today in this video I am going to explain you the percentage composition, empirical formula and the molecular formula. So first of all I will explain you what is the percentage composition. So percentage composition tells us about the percent of the different elements or various elements present in the compound. So first of all, to get the percentage composition, we should know about the chemical formula of that compound. So here if I take a calcium carbonate for example, and then I will ask you to calculate the percentage composition of different elements present in the calcium carbonate. So how will you calculate? So first of all you have to write the molecular formula or the chemical formula of the compound. This is the compound, and again first step is to find out the molar mass of that compound. So this is the molar mass of compound. Here these are the 40. So atomic mass of the calcium is 40 gram and carbon is 12 and oxygen is 16. So the molar mass of this calcium carbonate is 100 and the percentage of calcium carbonate in this 100 the percent is 40. So 40 upon 100, 4 percentage you will multiply this with the 100. So it is again for a very simple example, and it is easy to understand understand for you that the percentage of the calcium carbonate is 40, 12 and 48%. So first of all I want to tell you the formula by which with the help of that formula you can get the percentage of the various elements present in the compound. So the percentage of element is equal to the mass of element in compound. Mass of element in compound. So here 40 gram is the mass of calcium in this 100 gram molar mass. So again the mass of the element in compound and the molar mass of the compound, so and multiplied with 100 to get the percent of that element. So it's very simple. So again I take the second example. This is H2O, and H2O, the molar mass of the H2O is 2 plus 16 and the percentage of hydrogen is 2 plus 2 upon 18. The mass of element in compound is 2 and the molar mass of the compound is 18 into 100, and the percentage of oxygen here, the mass of the element of the oxygen is 16, so 16 upon 18. This is the molar mass, and 100. This will be percentage, and this is your homework. Find out the percentage composition of the sodium salt. Sodium salt, or you can say sodium chloride. So the molar mass 58 or so 23 upon 58 and so on. This is very simple percentage of composition. I have told you, explained you how will you get the percentage composition. Now I am going to that from this the percent you get the percentage composition from the molecular formula. Now how will you get the molecular formula from this percentage composition? This is the percentage of different elements in a compound. What will be the molecular formula? So this molecular formula and this percentage composition are reversible, interconvertible, you can get the percentage composition from the molecular formula and the percentage composition from molecular formula you can get the percentage composition. Now I am going to explain in the same way how will you get the molecular formula when the percentage composition is given. Suppose take the example of this calcium carbonate. Here I have given a table for you. So to get the molecular formula from the percentage composition, you have to calculate you have to take some steps. So steps, what are these steps? First, this is a very simple. This is the table, and this is the name of the element. This is the atomic mass of the element, and so the mass of the substance. For this percentage, we assume that the mass of the substance is equal to 100 gram. So this percentage is converted into 40 grams. So percentage, if we consider the mass of the substance is 100 gram, then this 40% will be equal to the 40 gram. This is 12 gram. These are the formalities, only percentage. This is the main step. Find out the number of moles of element present in the substance. Find out. So how many moles are there of the particular element in that compound? This is the main step. So how will you get this step? I have written number of moles of element is equal to mass of the element. This is the mass of the element in the compound, and the molar mass of the element is equal to the atomic mass of the element. I have shown it, molar mass and atomic mass. So again, how will you get those? So moles of calcium, number of moles of calcium is equal to 40 upon 40. This is the molar mass, and this is the, so it is 1, and the molar mass, this is percentage 12 gram and 12 gram equal, so it is 16. So again here the percentage is 48. I have done some mistake here, so you will write here 48, and you will write here 48, and you will write here 48. So the number of moles of oxygen is equal to 3. This shows. This is the ratio. Now this is the ratio of the mole 1, 1, 3. So the ratio of calcium, carbon and oxygen is 1, 1, 3. This ratio called as simplest ratio of moles. Simplest ratio of moles. So the formula of this compound will be Ca, C and O will be 3. So this is the formula of that compound. In this way, you can calculate, you can find out the molecular formula of that compound by giving from the given mass, so percentage composition of that compound. But here now I am going to explain you what is the role of this empirical formula. What is the role of it? I will explain you with an example the role of the empirical formula and what is the definition of the role. But before going to this, I am going to explain you one more example to get to show you how will you find out the percentage composition, and how from that formula how will you get the molecular formula. So I take a special example for you, that the example is if you are given a green vitriol. Do you know about the green vitriol? Green green vitriol. Green vitriol. Green vitriol is crystalline ferrous sulfate. So the formula of the crystalline ferrous sulfate is FeSO4 7s2O. 7s2O. Here the 7s2O. It is I am telling you about the green vitriol, or the chemical name of the crystalline ferrous sulfate. Crystalline ferrous sulfate. FeSO4 7s2O. When it is the color of this ferrous sulfate is green, so it is called as green vitriol. When it is heated, so this is the FeSO4 plus 7s2O. The AS2O is evaporated, and this is the dehydrated FeSO4. Now it is white in colorless. It is white FeSO4. So I don't go for this commission. I am only want to tell you find out the percentage composition of this green vitriol or crystalline ferrous sulfate. So again, I am doing it again. So this is first of all, you will write the formula of FeSO4 and 7s2O. We have to find out the percentage composition of green vitriol or crystalline ferrous sulfate. This is now here the molar mass of this ferrous sulfate. Molar mass of this ferrous sulfate. Molar mass. So now I want to tell you there are 4 oxygens. And this oxygen is 7 oxygen. So this 7s2O, or this crystalline, this S2O called here crystalline water. And this crystalline water is absorbed by the compound. So it is not the part of composition. It is simply added. It is simply added with the compound. So we will show this S2O with other separately. We will show the percentage of S2O separately in the percentage composition. So again, I am going to only my point is to tell you about this S2O. Otherwise, you have understood about how will you get the percentage. Percent composition. So the molar mass Fe 56. The atomic mass of Fe. Sulfur is 32, and there is oxygen only 4 oxygen. 64 you can write here, and again this is 7s2O. 7 into 18 is equal to 126. You will write here 126, and this is 278. 270, the molar mass value you will write here in the 78 gram. So again, the percentage of Fe, the percentage of Fe is equal to 56 by 278 into 100. This will be the percentage, and the percentage of S is equal to 32 by 278 into 100, and the percentage of O is equal to 64 by 278 into 100, and the percentage of S2O crystalline water is equal to 126 upon 278 into 100. These are the percentage of the various elements that are present in the here. This S2O is written as here the percentage of S2O. Now after calculating, I have some values of here 20.14. It is the value of 20.14%, and this one is 11.51%, and this one is 23.02%, and the third one is 4th one is 45.32%. These are the percentage of the different elements that are present in the FeSO4. Now I am going to explain you this formula. How will you, if you are given, now the second question is that the percentage composition of a compound is such and such, F is equal to and has been such. Find out the molecular formula of that compound. So again, by this table, from this table, with the help of this table, you will get the molecular formula. So you will write here Fe, SO, and H2O. So again, the Fe, you can write here Fe is equal to 56, 32. These are the formalities only to learn about this is 18, and the percentage is 20.14, and this one is 11.51, and this is 23.02, and this is 45.32. So this is the percentage. So again, this is the percentage. How will you get this is the percentage? You can calculate you can convert it into grams. So again, the main thing is the percentage should be divided with the molar mass of the, again, 20.14 upon 56. So you will write here 20.14 upon 56. Here you will write 11.51 upon 32, and here you will write 23.02 upon 16, and 45.32 upon you will write divide by 18. So the percentage is divided, or from the percentage you will get the mass of the element, and the mass of the element is divided by the molar mass of the element. These are the molar mass of the element. So here you will get here something 0.36, and here you will get 0.144, and you will get here 2.52. This is the value. So again I check it, say yes, the 0.36 and 0.36. This is the number of moles of the elements. Now here I want to explain it. In my previous example, I couldn't explain the simplest ratio of moles, so that I have taken this example. Because what do you mean by the simplest ratio of moles? This is not the simplest ratio. How will you get the simplest? Find out the least number of moles in this, and divide. This is 0.36 is the least among these four values of moles. So these all fours will be divided by 0.36. You will write here 0.36 by 0.36. This is the way to find out the simplest ratio of moles. So 0.36 upon 0.36, and 1.44 upon 0.36, and 2.52 upon 0.36. So here my aim was to tell you that what is the meaning of the simplest ratio of moles. So these are the number of moles. To find the simplest ratio of moles, you will divide by the least number of moles, in which find out the least number. This is the list, this is the list. So you can divide from this. This is the simplest ratio. So again, you will find here 1, you will find here 1, you will find here 4, and you will find here 0.6, 0.7. This is the formula of FPS of Fe1. Fe1, S is equal to 1, O is equal to 4, and 7S2O. So I think that I have told you, I have explained you that how will you calculate the percentage composition from the molecular formula, and secondly, how will you find the molecular formula from the given percentage composition of that compound. But again, I couldn't explain you this is the empirical formula. This is the empirical formula, and I couldn't explain you the whole number, the simple whole number. The simple whole number, suppose here, I think that I will explain you the simple whole number. Simple whole number means when you get this number 11147, suppose for the case of potassium dichromate, K2Cr2O7, you will find here K is equal to 1, Cr is equal to 1, and O is equal to 3.5. This number 114, instead of 114 complete number or the whole number, you will, in potassium dichromate, you will find here potassium is equal to 1, Cr is equal to 1, and O is equal to 3.5. Then you have to write here the simplest whole number ratio of mole. Whole number. It means you have to multiply again to make the whole number 2, 2, and 7. This is the meaning of whole number. So this is the definition of empirical formula. The empirical, now you can define the empirical formula as the simplest whole number ratio. The empirical formula represents the simplest whole number ratio of elements present in the compound. And the molecular formula shows us the actual or the exact number of elements present in the compound. So these are the two definitions of the empirical formula and the molecular formula. But still I am not satisfied that I have explained you the empirical formula. I will give you example to make you understand. I am giving one example to make you understand about the empirical formula, that how will you get the molecular formula from the empirical formula. Now I am going to explain you the concept of molecular formula and the empirical formula. This empirical formula, by multiplying with a constant n, this empirical formula can be changed into a molecular formula. And we can get the value of this constant n with the help of this formula, the molar mass of the compound upon mass of the empirical formula. Or you can say, when the molar mass of the compound is divided by the mass of the empirical formula, we can get the value of n, and that will be the value of n. So here again I am coming to my previous table that here I have told you about the definition. I write the simplest whole number ratio of the moles, that is the empirical formula. So if you are asked that what is the empirical formula, define the empirical formula, so you will say the empirical formula represents the simplest whole number ratio of atoms, of elements present in the compound. I have written here represents the simplest whole number ratio of atoms, of elements present in the compound. This is the definition of the empirical formula. And the molecular formula shows us the total number of atoms, of elements present in the compound. So this is all about. So now I am going to occur to what is the need of this empirical formula. So again, in inorganic compounds, this empirical formula is generally equal to the molecular formula. So this ratio that shows the empirical formula, this ratio is equal to the molecular formula as I explained you in calcium carbonate. But now I am giving for the organic compound, I have taken two things. One is one first compound, this is SCHO. This is SCHO. This is methanol. And the composition of the formaldehyde, this is also called as formaldehyde. So here first of all, find out the composition of formaldehyde. So the molecular formula of the compound CHO, CH2O. So the molecular mass of the 12 plus 2 plus 16, it is equal to 30. So it is, and this is the composition 12 upon 30, 2 upon 30 and 16 upon 30. So the percentage composition in the formaldehyde, the carbon percent is 40%, hydrogen is 6.67% and oxygen is 53.3%. This is the percentage composition of the formaldehyde. Now take the example of the second one. Find out the composition of glucose. The molecular formula of the glucose is C6H12O6 and the molecular mass of is equal to 72, hydrogen 12, so 12, oxygen 6, 16 into 6, 96, so it is 180. And again, you will get the percentage of the carbon percent here 40%, because 72 upon 80, 12 upon 180 and 96 upon 180 into 100. So this is the percentage composition of glucose. So here in this case, both the compounds, this one formaldehyde and the glucose, both the compound have the similar identical percentage composition. And from this composition, take any one of the compositions. I have taken here CHNO 40%, 60, 40%, 6, 7, 6. I have taken 40 and 6, and this, and again, divide this carbon by 12. This one is 3.333. These are the mole ratio. These are the mole ratio that is present in that compound. Mole ratio of the elements present in that compound. Now, the question arises, how will you get the simplest ratio? So here, these are the three entities, 3 by 3, to find out the shortest entity and divide this with the shortest entity or with the the smallest number of mole, this 3.33, this divide these three all numbers with 3.3, so it is 1, 2 and 1. This is the simplest ratio. If you take the example of CHO, SCHO or the formaldehyde or for the glucose, the empirical formula of both the compound is same, is equal. The empirical formula of the formaldehyde or methanol is CH2O, and the empirical formula of this glucose is also CH2O. So here question arises, how will you find out that this empirical formula relates to formaldehyde or this is glucose? So again, so here you have to find out the value of N. This N is equal to the molecular mass of the compound. So again, the molecular mass of the compound will be given in your numerical. If the molecular mass of the compound is 30, if the molecular mass of the compound is equal to 30, N is equal to 30, molecular mass of the compound for SCO is 30. So the molecular mass and the mass of empirical formula, is 12 plus 2 plus 16, so it is 30. So again 30 is equal to 30, it is 1. So the molecular formula will be CH2O. This is the molecular formula for the first thing. But for the second case, here the molecular mass of the glucose is 180. So the value of N is equal to 180 upon the mass of the empirical formula. The mass of the empirical formula is 30. So again you will have here 6. So CH2O is multiplied, N is equal to 6. So multiplied by 6. So the formula will be C6S12 or O6. This is the formula. In this way, you can get the molecular formula by multiplying with this N constant. At this N constant, you can get by dividing the molecular mass with the mass of the empirical formula. So now I am giving to a very good numerical for you that will be help to understand more clearly about the percentage composition and the molecular formula and the empirical formula. This is a numerical for you. First of all, write down the numerical. What is the numerical? A welding gas that is composed of carbon and hydrogen is burnt with in the presence of air that gives 3.38 gram of carbon dioxide and 0.690 gram of H2O. So by burning the gas, we don't know what amount of the welding gas is burnt. Only we have the data, we have the value of the carbon dioxide. So 3.38 gram of carbon dioxide is formed, and 0.690 gram of water is formed from that gas. And again, if the 10 liter of that gas at STP, the mass of the 10 liter gas of that gas at STP is 11.6 gram. Find out the molecular formula of that gas. Very good numerical. From this, so here only you have the amount of carbon dioxide 3.338, and the amount of H2 is 0.690. So this carbon, the amount of this carbon you will get from this carbon, the amount of hydrogen you will get from this hydrogen. So again, how will you, the amount of or the mass of carbon in this is the carbon, so the mass of this is carbon dioxide. Now 12 gram, so 44 gram CO2 contains 12 gram carbon dioxide, sorry, carbon. This CO2, the molar mass of CO2 is 44, and this 44 gram of carbon dioxide contains the 12 gram carbon. So 112 upon 40, and you have the amount of carbon dioxide 3.38. So the mass of carbon in this carbon dioxide, this amount in this carbon will be 3.38 is equal to 9.23 gram. This is the mass of carbon. And now you have to calculate the mass of hydrogen which is present in this H2O, 6.90. Again, the 18 gram of water contains 2 gram of hydrogen. So for 2 upon 18, and 0.690 gram will be 0.69 is equal to 0.077. In this way, from the amount of this carbon dioxide and hydrogen, we are able to calculate the amount of carbon and the amount of hydrogen, and that is 9.923 gram carbon and 0.077 gram hydrogen. Now you will have to calculate this amount, you will convert this amount into the percentage composition. Percentage composition, how will you calculate? So get the total amount of carbon and hydrogen, the total mass of carbon and hydrogen, the total mass of carbon and hydrogen, this and this, 0.923 plus 0.077 is equal to 1 gram. Is equal to 1 gram. Now this 1 gram contains 0.923 gram of carbon. So you can calculate easily the percentage of carbon is equal to 1 gram contains 0.923 carbon. This 1 gram contains 0.923 carbon, so 1, and the percentage will be here. So 0.923 upon 1 into 100, 92.3% sure. This is the percentage of carbon. In this same way, this 1 gram total amount of the carbon hydrogen contains 0.077 gram of hydrogen. So the percentage of 0.077 upon 1 into 100, 0.77. In this way, from this data, you calculated the percentage composition of the carbon hydrogen in this welding gas. Now, from this percentage composition, you will get the empirical formula. How will you get the number of moles of carbon? The percentage composition must be divided or should be divided with the molar mass of the carbon 12, as I told you here, this molar of the element mass or the percentage of this is the percentage. So again, it is equal to 0.779. This percentage will be divided by the atomic mass of carbon, that is equal to 0.77, and this percentage will be divided by the atomic mass of the hydrogen to get the number of moles. So here 7.7 upon 7. Again, both the number of moles of the percentage 7.7, 7. To get the simplest ratio of the moles, you will divide 0.7 by 7 upon is equal to 1. 7.7 is equal to 1. So the number of carbon moles in that compound is 1 and the number of moles is 1. So the ratio of the carbon and hydrogen is 1:1. So the empirical formula of that compound will be CH. Now, how will you find the molecular formula? So this CH should be multiplied with N constant. So this will be the molecular formula of CH into N. This N, how will you get this N? The value of this N is equal to the molecular mass of the compound and the mass of the empirical formula. So the mass of the empirical formula, you know that the CH, this is the CH, carbon 12 plus 1. So this 13 is the mass of the empirical formula. But what about the molecular mass of the gas? What about the molecular mass of the gas? So this data, the 10 liter at STP, the mass of the 10 liter STP of that welding gas is equal to 11.6. So here again you can say the 10 liter, the mass of 10 liter mass is equal to 11.6. So you can convert this, find out the mass of 22.7. Because the mass of the 22.7 liter at STP of any gas is equal to the molar mass, as I told you in my previous video. So here from this, the 10 liter, the mass of 10 liter of that gas is equal to 11.6. So for 1, 11.6 upon 10, 11.6 upon 10, and you have to calculate 22.7 liter. So the 22.7, this will be the molecular mass of that gas. So the molecular mass of that gas is 26.2 gram. From this data, you can calculate the mass of the molecular mass of this welding gas. So here N is equal to, the molecular mass is 26.3 upon 30. 13 is the empirical mass of the empirical formula, the mass of the empirical. So N is equal to 2. N is equal to 2. So here this N, CH multiplied by 2. So again you can write it CS2, and this is acetylene. This is acetylene. This, or you can say it is ethyne. It is the IUPAC name of this gas is ethyne. In this way, this is the very good numerical. From this numerical, if you go through the numerical properly, please pause this video and try to understand how I calculate this problem, and I try my best to make you understand to solve by solving this problem. So this is I think that this is the conclusion of that whole video. So that's all for today. Please like it, share it, and subscribe it. If you subscribe it, you will get the notification of my coming video, and that will be very helpful for you. So that's all for today. Thank you very much.